Unpeeled. And sorry you don't get to see my face today, and the audio will be wonky, as in you can only get it on probably one speaker, not a stereo, so sorry about that, but my internet is unexpectedly being very horrible today, so this would be the best way to record it and then upload it so you can, yeah, so it wasn't too choppy or too unintelligible, so apologies about that. But we have some good news. So it's from the University of Missouri, and Yan Lin, Jacob Search, and Alriza Majubnia have found a way to use humidity to 3D print objects. So essentially, they're using polycarpolactone, which is like my favorite material in the whole world, and they are dissolving it in a material called tetrahydrofuran, THF, which I've never actually heard of. But anyway, when the resulting solution is exposed to humidity, the solvent diffuses, dissolves, and you solidify the polycarpolactone polymer. And you have a part. You have a freestanding part that is not made without support. Now, this is a completely novel 3D printing method, well, at least as far as I'm concerned. I've never heard of anything quite like this. I've never even thought of anything quite like this, and I've spent a lot of time working with polycarpolactone. So it's really amazing. I think it's a wonderful thing. They call it 3D printing of selectively porous freestanding structures via humidity-induced rapid phase change. There's a paper. They can make structures about 159 microns. And they have a print speed of about 25 millimeters per second. Now, okay, so from an IP point of view, this is a completely new way of doing things. It's very early, so we don't know what to do with it. The team thinks maybe they can make biomechanical parts, but that's probably because they print in PCL, and PCL is very suited for bioreabsorbable. There's variants of it that have approval. It's being used in the body. It's very safe. It doesn't cause cancer, that kind of thing. So it's a very safe material. So it's very obvious that they would lean towards this because this is the build material they're using. But one could imagine there could be completely different ways of doing this, and in inside certain structures, or doing this maybe potentially this is much faster to do this along a wide area or something like that. So it's it's a very exciting. I'm very excited by this. I think this is actually really great that somebody just managed to figure out a way to use humidity and to take a precursor and turn it into like a polymer structure. Fantastic. The next thing is a work by 10 SEMC, the Paul Scherrer Institute, or PSI, and the Swiss Paraplegic Foundation, or SPS. And they worked on a 3D printed cushion. Now, first off, I think there should be much more collaboration between patients and patient groups and patient representatives with caregivers, and also just generally 3D printing. We can create novel solutions for their problems. We can create novel structures. For a paraplegic, we can create a solution just for that one person, for her problem. And that's something unique to us. So we should have more of this happening. I think it's absolutely fantastic to go directly to the user group, to the advocates of these people, and say, hey, what do they need and how do we develop it? So this should be happening more. Now, what have the team done? They've 3D printed a cushion. So what's this cushion for? This cushion is for people who have to spend a lot of time in wheelchairs, maybe throughout the day or maybe every day, such as paraplegics. And what they've done is they've developed it so that it reduces pressure injuries, which is a problem for somebody who's spending an awful lot of time in a wheelchair. It's got a lattice type of structure. It should get better breathability and wicking properties, right? Which of course, imagine you're sitting on this all day and it's kind of plasticky feeling and it's all humid and kind of warm. It's not better. It's better. There's temperature regulation thing as well, so that's also good. It's also washable. Now, the current alternatives are made by hand. They're very costly, they're expensive. And now this could be a alternative for a lot of these people that could be much more cost effective. And what the team is looking for is a 3D printing partner to make these large kind of flexible structures. I think it's absolutely fantastic for something like rapid liquid print, or what is Architected Materials guys, OPT. This is absolutely fantastic idea, and I think this is a fantastic application. Not only for this, but just regular wheelchairs, or car seats for truck drivers or UPS drivers that spend like a lot of time behind their car seats. or just seats behind the office, headrests. I think cushions are one of my favorite 3D printing applications. And I think this is an absolutely fantastic implementation. This is a high value, high specificity, really, really high kind of societal impact kind of thing that you could be doing. It's a wonderful business case. I think it's fantastic, and so I think it's really, really great. This. The next thing, which I had completely missed, which was kind of weird, that on GitHub there's a project to promote 5-axis 3D printing. We all know we work in 3 axes, and well, that's good for some things, but if you want to make really complex structures, if you want to make really large structures, or if you want to make structures that are kind of conformal to things, it's kind of a bit limited. Now, 5-axis has been something that maybe, really large construction robots have been working on, or people using like robot arms and stuff like this have been working on it. But generally, the software is not very accessible. It's all proprietary, super expensive, all closed off. The robot arms and all these 5-axis or more equipment is typically really expensive as well. So what these guys are doing is they have a GitHub project where they're trying to make 5-axis 3D printing kind of something that you or I could do. What they're doing on the one hand is having a path for you to upgrade your existing Prusa or Vora or another 3D printer, E3D tool changer as well, to a 5-axis machine. So I think, I hope that a lot of people look at that, and some people, I guess, it's a pretty niche thing, I think, for now. It'd be, oh my god, that's so cool. I have a spare kind of MK3 or something lying around. I'm going to turn that into a 5-axis machine and see what I can do with it. So that's really cool. The next thing, what they're trying to do is to make the slicing software, the actual interface, and getting these files made for this 5-axis 3D printing more accessible. Now, the project's headed up by Freddie Hong, who's at the Dyson School of Design and Engineering at Imperial College London. There's a video, by the way, I'll link to the video, and then you can see his explanation of this, and I think it's fantastic. And the team have already showcased an explanation. We're onto a curved object. They're 3D printing electronics, and they're 3D printing multiple materials using this 5-axis technology. And that's exactly where it shines. Think about making things that fit on your arm, for example, or things that you print on top of something. And that's the kind of thing where 5-axis really can make a difference. And yeah, I think this is a path that we're not exploring, and we should be exploring. So, yeah, kudos to Freddie Hong and all the guys for doing this. And I'm absolutely flabbergasted. I missed this entirely, this development. I thought this is absolutely fantastic. I hope you do too. This is another edition of 3D Printing News Unpeeled. Have a wonderful